Hang, and my metric number is AE190098. So now I would like to present about the ladder diagram for the question assignment. So there will be a few components we use in this ladder diagram. So the first is the SB1, which will be the start button 1, C1 the relay 1, S1 will be the solenoid valve 1, C2 will be the relay 2, and the FS will be the float switch. T on will be the first timer which will trigger for 120 seconds. However, we use here will be the 12 second to shorten the video length. And another on timer will be the 90-second timer. However, here we use the 9,000 millisecond, which is equals to the 9 second to shorten the video length. And the S2 will be the solenoid valve. So SB1 will be the normally open switch. So when we force through it, it will become normally closed. So it will allow the current to flow through it. So when current flows through the SB1, C1 and S1 will be on. So when S1 fill the fluid to certain height, it will trigger the float switch. So when float switch has been triggered, the timer will on for 12 seconds. When the timer is is to 12 seconds, it will open the C2 and the S2. So another for 90 seconds, it will reset the C2. So the C2 will be open. So S2 will be open also. So that's all for the ladder diagram.
Hi doctor, good day. My name is Nityan Raja. My matrix number is CE190043, and today I would like to present about the proposed ladder diagram and the truth table for this ladder diagram. So this is the proposed ladder diagram as shown in the slide, which consists of X1, Fs as input and S1, S2 as output. LED1 and LED2 is added for indication that S1 and S2 is active. So relays and timers are added based on the instruction given in the author. So this is the ladder diagram that we are proposing for the working of the fluid storage tank. So let's look into the truth table for the proposed ladder diagram. So as you can see, this is the truth table according to how the fluid storage tank functions and the suggested ladder diagram. Zeros and 1 determines the state of the value or switches which is off or on. So X1 and Fs, as stated before, this is the input of the system, and S1, S2 is the output of the system. So when X1 and Fs is in off state, the S1 and S2 will be in off state also. So we can assume that the tank is empty. When the X1 is switched to on state, S1 will be on, which will fill up the tank. When the tank is reaching full volume, Fs will be triggered to on state, which triggers S2 to be on to flow the fluid out of the tank, and it also will close the switch 1 based on the timers and relays in the ladder diagram. So this is the simple truth table representation for the proposed ladder diagram based on the input and output. So that's all from me. Thank you, doctor.
Assalamualaikum, my name is Nur Sharika Azwa binti Mahmudi. I want to present the economic aspect and about the PLC diagram discussion. The change that has been made is to remove all the control relay in the PLC to reduce the cost. For that, when the push button is given force through, a connection will occur with solenoid valve 1 on rung 1, and a float switch is installed in parallel with the solenoid valve 1. Next, force through on the float switch will connect all circuit and active the T on 0 timer, which is delayed for the 12 seconds. And after 12 seconds, continue connecting solenoid valve 2 and T on timer 1 for the 9 seconds. After the 9 seconds, continue disconnect the solenoid valve 2. Okay, next, presenting the economic aspect of the control process to make operation efficient and can achieve cost effectiveness. Among them are the low cost. Do not use the relay as long as the PLC is running. The relay is controlled by the PLC. Relay can also be used for simple control scheme where a PLC will be improved uneconomical. Second, product quality and reliability. The relay system in the PLC is made of the solid state. Traditional mechanical relays wear out faster than solid state relay called electronic, and about the arcing can destroy contact in the long run. If the something breaks, fixing it takes a long time and is difficult. Third, making decisions that are easier for the management. PLC simplify the problem solving, and relay output cards send one wire to output device. PLC system with a several output and significantly easier to troubleshoot than relay system with 4 times as many connections. Next, 4. Reduce the labor cost. PLC systems are adaptable and expandable unlike the previous relay system. A PLC timer can be added to the program to turn on the motor after 5 seconds. The timers must be wired to a motor, and can reduce the development cost, can component cost and labor saving, and pay someone to install and wire new relay-based components. That's all for me, and thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Fikri Haris Bespawi. My matrix number is AE190041. We explain about the safety value for this PLC. So, in order to get the safety for this PLC, we added one push button. As you can see from the picture, this push button PB1, it will act as emergency button. So if anything happen from the filling process control, this button will stop the overall of the operation. For example, when S2, which is solenoid 2, does not work, this push button will shut down the entire system. Next, we add relay. Every power rail we connected with a relay. So if any component in the power rail fails to function, the system still can be work. The operation still can be operated even though the maintenance for failed components still not solved. So this is for the safety value. Thank you. Nah,